Good afternoon, everyone. My name is DeLong. This is Ping. We're from the Custom Vision team. And here today, we're very happy to be here to talk to you about how to make your own object detector under 15 minutes. So, little background, Custom Vision is a cognitive service. It's a set of services offered on Azure that brings the capability of AI to your applications really, really easily. All you have to do is to make some REST API calls, and you can have computer vision, you can have speech, language understanding in your applications.
Hello, so I'm Ping. So basically, we are the Custom Vision team. So by Custom Vision, we mean you can upload your own data and train your own model for your own task or goal or problem. So you can solve your own problem with the Custom Vision. So last year, we introduced this classification service in our Custom Vision. So basically, classification is after you train a model, for example here, they're trying to classify keyboard and mouse. So you give us a new image, and we tell you whether it's a keyboard or mouse or both. So this is a classification service. So here, so for example, this image is telling this image is a keyboard and a mouse. So our customers really like our service, as we are powered by deep learning, so it performs pretty well. But they always ask us for more details in the predictions. So can we give them more details? They're always asking, can you tell us where the keyboards are, where the mouses are? So basically, this is the object detection problem. So here, if you train a model for the mouse and keyboard detection, then this is what you get for the results. If you send this image, we are telling you those three mouses are over there, and there are two keyboards located over there. So we'll tell you the bounding boxes information of all those objects with a probability associated with them. So the reason we build this into our service is because building your own detection model from scratch can be very hard and time-consuming. You need someone who are really familiar with deep learnings and all those kind of fancy object detection models and hyperparameter tunings. Also, you need a powerful GPU machine to train these models because it usually takes a long time to fine-tune and train a whole model for yourself. So this year, we bring the object detection service into our Custom Vision, and it's available today at customvision.ai. So we make it much easier for you to do this task. So basically, on our web portal, our website, which is customvision.ai, you can upload your own images and label your data by just simply putting boxes around the objects of interest around the thing, and then click the train button. Then you get a model in a few minutes, and then you can send the images to your trained model and get your predictions. So here are some highlights about our object detection service. So basically, we are pretty fast. So if you have a project of 5,000 images, which is the current limit for the preview version of object detection service, so we can finish the training in 15 minutes right now. So also we offer interface. We offer a web UI. Basically, you can easily manage your images and label your images as well. We have feature called AutoBox. So before any training happens, this feature can help you identify some potential objects of interest you are interested in. So basically, if you hover your mouse over it, you can see some potential boxes. Also, we have a very easy-to-use API and SDKs available. So it's very easy for you to integrate our service into your own applications. Also, we host your model as a REST endpoint. So basically, after your training, you can send your images to the REST endpoint and get our prediction. So it's available right now, as I said. So it's this website, customvision.ai. So let's do some demo. Let me just walk you through the whole process of creating a project and train your own data set. So basically, I have so it takes too long to label tens of images. So I have a created project here, which is trying to detect the mouse and keyboard. So for yourself, it's very to create your own project. You have to upload some images. So for example, here we have it. So here's a keyboard and mouse picture. So you upload your own data set, and then you get it here. You can then, as I said, you can draw your boxes around the things of interest. So this is the keyboard. You can label as a keyboard. But what is even better is what even better is like, as you can see, when you hover your mouse over this keyboard, it's showing like there might be something over there. So, and you hover like your mouse over the mouse, it's the same thing. It said, so our algorithm is telling you there might be something of your interest. Also, like this is not something we're interested in, but like our algorithm still figure out that this is something. This is an object, potential object. So by one click and enter, I label this keyboard. You can sometimes it'll be off. You can just tweak the box a little bit. It's easier with a mouse. I just have a touchpad here. So this is a mouse and that is keyboard. After you label the data, just click here. So we are done. So here are all the tagged images, and one single click on the train button, we start our training process. So the training process for this size of a product usually takes 1 to 2 minutes. So to not waste too much time, we just look at a previous trained model here. So this is some result for a previous trained model. So after your training finished, you can quickly test. We have this prediction URL. Basically, this is how you can send an image to your trained model to get a prediction result on some new images you have, like the image we show in the slides. So here you can send an image URL to the service. Here you can send an image file. So to do a real quick example, we have a quick test here, which allow you to quick test your model by some images you upload. So we have another image in the picture folder here. It has a lot of keyboard and mouse over here. So as you can see, this is a prediction result of the trained model. So here you got a few. We got a lot. This red box are the predicted objects. So we got all those like mouses labeled predicted, and those like keyboards. They are all associated with some confidence. So for example, this one, it means, so our algorithm thinks this is a keyboard with a 98.7% confidence, things like that. Okay, so Delon is gonna help me tell you more about this, how to interpret this result. Also, our training just finished here, as you can see moments ago. So.
Cool, awesome. So now we have a trained model. We have tested an image, and it works pretty well. And as you can see, each box here has a percentage associated with it. That's the probability of how confident the system is that this is a keyboard. Well, for your applications, you will probably choose like a certain number below which you just consider that to be a bad result. That's what this slider is for, the probability threshold. And as you increase it, less and less boxes are going to show up. So it's going to filter out all of the ones that are below 78%. So how to choose what number to use here? So we built this pretty helpful tool for you. When we trained your model, we also did some estimates on how well your model might perform on your production data, on data that you will send once it's deployed in production. It's falling off. So here you will see the same probability threshold slider. And as you slide it, these values, precision and recall, will change. So what you have to understand for prediction and recall is that it's usually a trade-off based on which application cares more about. So let's say that your application will try to detect something and automatically perform an action on it, then you probably want very high precision. You don't want to accidentally trigger an action on something that's not very confident about. On the other end of the spectrum, maybe your application is something that will detect regions of interest and send those regions to a future human judge for evaluation. Then you probably want high recall because you don't want to miss anything. So like I said, it's really a trade-off, and you can just see how that trade-off is going to play out as you change this probability value. And you will use that value inside your application to consider anything above it to be good enough. And then we also have this third metric called mean average precision, MAP. It's a more advanced number that will describe your model like in general, holistically. And one way that I use this number is really to evaluate how your model performs in between iterations, training sessions. So if it increases, the better job than last time. So let's switch back to the slides. Shift F4? Oh, shift. No, no, no. No Cortana. No. Okay. Okay. So we just talked about those. We'll just skip them. So now we'll give you some tips on how to build the best model possible using our tools. So one thing is, one, you choose what you care more about, high precision or high recall. Or maybe for your model, you will have high numbers for both, then that's good. And two, train on data that you will see in production. So for example, we trained a object detector on just that copper mug. Then that model is not going to be able to find plastic cups, or like a mug, but from like above. So if you want to do those cases, that's totally fine, but you just have to give us more data of those type. Let's do that. And thirdly, label your data well. Don't miss anything. So in that image below, you can see that we have 3 pens, but we only label 2 of them. What this is going to do is it's going to tell the model that the first thing is a pen, the last thing is a pen, but the second one is not. So the model will get very confused on what is a pen and what is not. So don't miss anything to the best of your ability. And if you do miss something, then you can go back into your model and then label them, train again, and it's going to take a couple minutes. And lastly, avoid very, very small objects in the image. So for example, this, I don't think anyone can tell what that thing is. That's a USB adapter. So maybe not try to do detection on those objects. Or if you do want to, then zoom in a little bit. Or have a higher resolution image. So to recap, we are a cognitive service called Custom Vision that allows you to train your own object detector very quickly. So if your problem has about 5,000 images, it's going to train around under 15 minutes. We do have a very easy-to-use UI that can let you label your data really, really quickly. And if you prefer to use APIs, we do have a whole set of APIs that the UI essentially uses to do everything it does. So you could just use the APIs yourself. And we also do have SDKs and samples. And finally, once your model is ready, it's trained, we will host it as a REST endpoint. So all you have to do is to make REST API calls to that endpoint, and you will have object detectors in your application. And we are free to try today. It's available on customvision.ai. So yeah, give it a try. Yep, that's it. So we'll take some questions. I think our session ended a little earlier because we started earlier. So we'll just have more time for questions, I guess. Yes?
How accurate would this be on face detection?
So the question is how accurate it is for face detections. Cognitive Services does have a separate face API that will do better on faces. So you should just use those for face detection. Yes?
Do you have a format you can use for testing, or do you have to create your own?
Yes. OK, so for object detection, we currently do not have a mobile run on device version. But your app could always just make REST calls to the API. Custom Vision does have a classification service, the one that we announced last year. That one does have export capabilities, so you can download your model and run on device.
Do you have an app where you can use that?
Yes, so we do have a Android and iOS sample code on GitHub. So those are open source, and all you have to do is put your model in, and you're good to go.
What's the underlying algorithm that you use to do the object detection? And yeah, that's the first question.
Oh, so
You want to answer that?
so the question is, what's the underlying algorithm? It's kind of it's not really typical. We modified our existing algorithm, so we make our own network architecture to do the job.
Okay,
Well, yeah, it's modified based on YOLO. But, so yeah.
So like you have pre-trained weights for extracting features that you mentioned?
That's too much detail, I think.
Drop by our booth. We'll talk later. Yeah, we are in Cognitive Services Vision next to the mixed reality demo booth. Any more questions? Yes.
Any interesting result you have found so far, like detecting dog or any kind of interesting result you have so far?
The question is, do we have any interesting results? Yeah, we do test on a whole lot of data sets, but if you do find anything interesting, try it out and let us know.
Yeah, so basically we test on a lot of public data sets, and it performs pretty well. Like on VOCs, it's like 74 MAP, things like that. So the results, we test on like many different data sets. If you are interested, like our booth is at Cognitive Service Vision, which is that area. So we have like an animal data set, like a result you can see, like, so we can show you more like a prediction results. Yeah.
Yeah, drop by our booth. We'll try something out. Yeah. Any more questions?
Will we be able to download the model in the future?
It's not available yet, so we are gonna work on we don't really have a timeline for it. So yeah.
Okay.
Yeah. But for the classification, we can explore right now. So
Yes,
yeah.
classification we can download the model.
Yeah.
Yeah,
So the question was, can we download the model? No, right now we can't. But like I said, it's all REST APIs. So even if it's a mobile app, you could just make a request and try it out that way. So. Okay, no more questions. Excellent. Yeah, please remember to evaluate our session. And there is another talk at 3 in room 612.
Yes, sorry.
612 about computer vision and further details on how custom vision and cognitive services in general work. So do drop by that breakout session on 612 upstairs. Cool.
Thank you.
Thank you.